So I'm Kevin McLean. I mentored Jake this summer on a project using a small telescope that's located in Northern California. Jake and I, and also my other student, who's coming up next, Zeke, we are all in California. We're all Californians, and the telescope's in California. It's a small telescope, and so it's good at doing a couple of things: measuring the brightnesses of things and measuring the positions of things. And I give my students a choice as to what sort of project they'd like to do. And so Jake decided he wanted to measure the brightness of something, and he measured the brightness of a star, type of variable star. And I will let you tell him the rest of that, or let him tell you, I'm sorry.
So my project was determining a light curve for a star called Delta Cephei. So here's the background. The telescope I've used is a 14-inch Celestron 1024 by 1024 CCD camera with a Johnson Cousins filter set. I did not actually go to a certain place to use the telescope at night, but rather I used a website and put in the relevant information, and then the telescope gave me the images, and then I downloaded them. Delta Cephei is a Cepheid variable star, meaning its brightness changes over time. The longer the period, the greater the average brightness. This happens because the star pulsates, meaning it gets bigger than smaller over time. Stars pulsate at a certain stage of their evolution. An example light curve is displayed on the right. So as you could see, goes up and then down and then up and then down again. It changes over time in a certain pattern. And here are my observations. I took photometric observations over 14 days and determined the relative brightnesses using a program called AstroImageJ. The photometry aperture is used to measure the brightness of the star plus the brightness of the sky. The sky annulus measures the brightness of the sky. So I need to know the brightness of the sky so I could subtract that off from the brightness of the star plus the brightness of the sky, so I could get just the brightness of the star, which is what I want. So this green circle right here is the photometry aperture. This red circle is the sky annulus. So to get the star's brightness, I subtract the result of the green circle and the red circle. And here is my data, which is similar to what I've shown on number 2. This is an example light curve right here. And this is the light curve I've taken myself. There is some missing data because of the weather, and some of my observations failed. They just did not go through because of weather issues. And to sum up, I've learned that some stars are not consistent in brightness, rather their brightness varies over time. And I've also learned that sometimes I have to handle technical difficulties and find a solution. And I've had several of these. One was the website that I had to use the telescope on. It often did not connect, and like sometimes it worked, sometimes it didn't. And I figured out that I should just leave the tab open at all times so I wouldn't have to worry about it anymore. And sometimes an image did not go through. It showed failed and I was not able to download the image. So both my mentor and myself took images, so that way if one of them fails, the other person would still have it. And the program I've used, AstroImageJ, had issues as well. I first downloaded the version 5.0, and it had an issue where a lot of after like the first few images, the second circle, the second aperture did not go on, like right here. And because of that, I was not able to do it. So I had to download an older version, and that version had another issue where the second aperture just went to the same place as the first one. And so what I did is I had my mentor do the ones that I could not do myself and then upload them to Google Drive so that way I could use them. And so I've also learned that sometimes I need another person to assist me when I'm having difficulties, because sometimes I cannot do things myself and technology can be complicated. So if I'm not able to figure out the solution to an issue, someone else might be able to. And there, there's one more thing is that I, I was not able to determine the margin of error, which is called an error bar, because I do not have enough data and I did not have enough time to do this as I only did this for 14 days. So this is what I was able to accomplish.